Okay, so I had these quiz problems and some had some confusion on these, so let's make sure we understand. Okay, first problem, you've got x cubed minus 2x squared plus 7 added to this. Well, you're just adding, and there's no number in front of it, so you don't have to multiply through by any number. We just distribute an addition through the whole thing, and we get this. Okay, well, so let's put these terms in order of decreasing powers. Okay, that's something you always want to do. Make yourself a note. Remember, you always put them in order of decreasing powers. After you get this mess, you sort it out. So the highest power is x to the fourth, so there it is. And then the next power is x to the third. And then we got a negative 2x squared and an x squared and an x. Okay, well, we got negative 2x squared plus x squared. And to make sure we understand why we can do this, we can add negative 2x squared to x squared. One way, yeah, common sense. You got negative 2 of them here, and you got 1 of them here. You got negative 2 of them, and add 1 of them, you got negative 1 of them, and you're going to get negative x squared. Now, you can do that, but I'm going to do it like this. I'm going to say this is plus x squared times negative 2 plus 1. Because if I multiply x squared by negative 2 plus 1, that means I multiply x squared by negative 2, which gives me the negative 2x squared. And I multiply the x squared by the 1, which gives me the x squared. This is the reason that you can then write this as x to the fourth plus x cubed plus x squared times negative 1. Which means, of course, I can write it as x squared plus x cubed minus x squared plus x. Now that's the long way to do it, and it's not usually the way we look at it, but this is why you can combine like terms, and you can't do that with unlike terms. You can't add an x cubed to an x because it doesn't factor this way. You don't get a couple of numbers here that you can add. It doesn't work. Okay? So you can kind of skip directly from this step to this step if you know the rule that you can only add like terms. But if you're never in doubt about that rule for why you add like terms, it's very helpful to understand why it works. So if you're ever confused, you can do this and see if it checks out. Okay. Well, I'm going to ask you to do another one. I'm going to ask you to do okay, can you read that okay? Okay, now let's look at this example. Yeah, I've got smudge. I'm sure I smudged. Don't remember doing that. Okay. So we're going to have, first of all, x to the fourth minus 3x cubed plus 5, just as it is, because there's nothing out in front of these parentheses. And then we have a 5 out in front here. Now this 5 means it's multiplied by this whole expression. So we've got to multiply 5 by each term. We've got to be sure we understand the distributive law. Okay, so it's plus 5 x to the fifth plus 5x squared minus 15, because of course 5 times x to the fifth is 5x to the fifth. 5 times x squared is 5x squared. 5 times -3 is -15. Now, having written this out, where everything's really easy to see, okay? I don't skip steps. I don't go from here down to the step where I've got them all in order, even though some people did that correctly. I don't think it's a good idea, okay? Even if I'm doing this and I don't want to make a clerical mistake, I'll write out this step before I rearrange it. Okay? Because we can see right where the 5x to the fifth came from. It's not over here, it's not over there, it's right where it ought to be. And 5x squared and 5 times -3. Now, if you skip a step and get it right, that's fine. But you're not going to learn it as well, even though it takes a little longer to write it out. If you skip the steps, and you're going to be more likely to make a mistake. Okay, so now we look for the highest power term, which is our 5x to the fifth. And then we have our x to the fourth. And then minus 3x cubed, that's a third power, and a 5x squared, and 5 and a -15. Now, where are my like terms? I only got one x to the fifth term. I've only got one x to the fourth term, only one x cubed term, only one x squared term. So all I can do is add the 5 to -15, and I get 5x to the fifth plus x to the fourth minus 3x cubed plus 5x squared minus 10. Now, I'm going to check this. Now let x equal 2. That's convenient because powers of 2 are pretty easy. Then the first step, 2 to the fourth minus 3 times 2 cubed plus 5 times the quantity 2 to the fifth plus 2 squared minus 3 equals what? Well, powers of 2 are easy. And if you use powers of 2 to help check, you're going to catch most of your errors. Okay, so I know 2 to the fourth is 16. That's minus 3 times 8 plus 5 times 32 plus 4 minus 3. That equals 16 minus 24 plus 5 plus 5 times 33. Well, that's 16 minus 24 plus 5 plus 165. And that all equals, well, that's minus 8 plus 5 is a minus 3. That should be 162. Now, I didn't leave myself enough room here. But now if I come back and check this term, so what I've done is I've just substituted 2 into this first expression. This first expression kind of comes down here, and I substitute 2. Now this last expression could also come down here. And if I put 2's in, I get 5 times 2 to the fifth plus 2 to the fourth minus 3 times 2 cubed plus 5 times 2 squared minus 10. There's a little arithmetic involved. That's going to be 5 times 32 plus 16 minus 3 times 8 plus 5 times 4 minus 10. And that's going to be 160. plus 16 minus 24 plus 20 minus 10. And if this doesn't come out 162, I'm going to be a little bit upset, but not much because mistakes happen. And it doesn't come out 162, so I probably made an arithmetic mistake. Well, maybe it does. 160 and 16 is 176. Add 20, we get 196. Subtract 10, we get 186. Subtract 24, we do get 162. Now, what I've just done is I've shown that if I let x equals 2, this first step and do all the arithmetic, I get 162. I get like a check mark. Down here at the end, if I plug x equals 2 in for the last term, I get this and do the arithmetic and I get 162, which tells me I probably did it right. Sometimes you can have a mistake here that cancels a mistake you made there and still come out looking like it's right and it isn't. So it's not infallible to check that way, but it's a very good idea. And when you're first learning to do these, you really ought to be checking. Plug in 2. Powers of 2 are easy. And you can get used to them pretty quickly. You probably want a calculator to do all this. Okay. And you can just plug this term, just put that into your calculator, press a button and get 162. That would be okay. Because all you're doing is checking. Although I do recommend doing some arithmetic because you get better at it and it can be helpful. Okay. So I'd recommend doing some of these by hand, but then use your calculator to check. And if you're pretty sure you did this right, and you're pretty sure that these didn't come out the same, check the way you put them in your calculator, go back and do the arithmetic by hand, whatever it takes. But you want to know on each problem whether you got it right or not just whether Open Math says it's right. Although, well, I'm going to give you a bunch of problems you're not going to know whether they're right. You're going to have to check them. Okay? Okay. Okay, now let's go to the second problem. We've got 4x squared plus 2 multiplied by x squared minus 3x plus 4. Now, by the distributive law, which we used on some of these problems, okay, like when we multiplied the 5 by this term, or by this expression, okay? From here, we're going to have to multiply 4x plus 2 by everything in here. I'm going to first write this out. It's 4x squared. I think I said 4x plus 2. It's this times x squared minus this times negative 3x plus the 4x squared plus 2 multiplied by 4. So now we see that I've got that 4x squared plus 2 here, here, and here. And it's multiplied by the x squared here, multiplied by negative 3x here. And I said minus this times minus 3x. I used the minus here. So 4x squared times minus 3x should be minus 4x squared plus 2 times 3x. Prefer to write it out this way because it gets confusing if you got too many plus signs. And anyway, that's the reason for it. Anyhow, there it is multiplied by x squared. There it is multiplied by negative 3x. And there it is multiplied by 4. Well, now we have to use a distributive law again, as it works on both sides. The 4x squared has to be multiplied by the x squared, and the 2 has to be multiplied by the x squared. So this means I got 4x squared times x squared plus 2 times x squared. And then I've got a minus here. So I'm going to write that as minus, and then I'm going to put some parentheses here. Okay, I've got a minus here, but then I'm just going to multiply this by this. 4x squared times 3x plus 2 times 3x. And I'll worry about that minus sign when I get everything simplified inside. And then it's going to be plus 4x squared times 4 plus 2 times 4. So once more, I've expanded this multiplication by multiplying this by this here and this by this here. And the pattern is always the same. Stuff we're multiplying will differ, but the pattern never varies. Okay. And then I've got a minus here. I'm just going to keep the minus and I'm going to use parentheses. And in the parentheses, I multiply the 4x squared by the 3x here and the 2 by the 3x here. And then I've got this and it comes out here. Well, now I do my multiplications. 4x squared times x squared is 4x to the fourth. 2 times x squared is 2x squared. And keep the parentheses. 4x squared times 3x. 4 times 3 is 12. X squared times x is x cubed. 2 times 3x is 2 times 3 is 6. Just have the x. And then it's 16x squared. 4x squared times 4. You multiply the 4s. And 2 times 4 is 8. Now, one step at a time, I could start combining things. You know, I've got a 2x squared that I could add to 16x squared if I wanted to. But I'm going to be careful. I'm going to be very methodical. And I'm going to just distribute the minus sign through this set of parentheses to make sure my signs are correct. 4x to the fourth plus 2x squared minus 12x cubed minus 6x plus 16x squared plus 8. Okay. Now I put everything in order. My highest power term is the fourth power, and it's already out there in front. But now I've got an x cubed term that'll come before the x squared term. So I've got minus 12x cubed. And then I've got a 2x squared and a 16x squared. And then a minus 6x and a plus 8. Now I have the like terms here. Two x squared and 16x squared. I could write as 2 plus 16 x squared. Because by the distributive law, 2 plus 16 times x squared is just 2 times x squared, which is here, plus 16 times x squared, which is here. I think it's a good idea for you to write that out if you're having a little trouble understanding the like terms thing. But if you really believe it, and use it consistently. Just use the idea that x squared terms are like terms. X cubed is unlike x to the fourth. A 6x is unlike an x squared, and so forth. And you can just kind of skip from this step to this step. So we kind of put this step in parentheses as not absolutely necessary, but not a bad idea. I kind of recommend it, but use it as you see fit. Okay. Then we can plug 2's in for all the x's here. We plug 2's in for all the x's here. And if you want to do a really quick and dirty check, just plug 1's in for all the x's, because then all the powers would be 1. Now that's not a good check, because there are a lot of ways things can go wrong, and you still x equals 1 is going to work. But if x equals 1, that's going to be 4 plus 2 or 6. That's going to be 1 minus 3 plus 4, which is 2. 1 minus 3 is negative 2, which is 4. So that's 6 times 2 is 12. If I add them up here, I get 4 minus 12 is minus 8, plus 18 is 10, minus 6 is 4, and 4 and 8 is 12. Okay, so an x equals 1 check will catch most errors, but not as many as an x equals 2 check. So, of course, you could use any number at all. You use 4,783 if you want to find the fourth power of that, but you don't. Okay, since you're going to put it in your calculator anyhow, 2 is not a bad choice, or any single digit number. Okay, 7 would be a good choice. Any single digit number would give you a pretty good check. Okay, well, that's the process. Now I'm going to give you another one to work. Okay, so let's try. This one. Okay, well, first to work through this, we're going to write this as 5x squared times x squared plus 4x minus 2 minus 2x times x squared plus 4x minus 2. Then we use a distributive law. We got 5x squared times x squared plus 5x squared times 4x plus, we do it this way, plus 5x squared times negative 2. Or we could do minus 2 times 5x squared, which will come out the same. We're going to have a negative on this product either way, okay? I did it differently over here. I'm doing it this way here. Then we have minus 2x times x squared minus 2x times 4x minus 2x times negative 2. That gives us 5x to the fourth plus 20x cubed minus 10x squared minus 2x cubed. I think maybe there was something, I saw a mistake on that. And maybe that came out as an x squared. So check that. You do the minus 2x times the x squared, and you get a minus 2x cubed. Make sure we got that. Minus 8x squared plus 4x. And that's 5x to the fourth. Okay, so we've completed the distributive law. So we use a distributive law to get this. We use a distributive law to get this. And we then multiply everything out, and now we put everything into order. So it looks like we got a plus 20x cubed minus 2x cubed minus 10x squared minus 8x squared, and then plus 4x, which gives us 5x to the fourth, 20x cubed. See how I wrote a square there when I meant a cube? I think somebody might have written a square on this negative 2x cubed. Okay. So if you did, it's a minor mistake because everything else looked pretty good. Okay, so we got 20x cubed. I've already got it. Okay, I'll put parentheses around this. We could write this as then 20 minus 2 times x cubed. And then it's, I'll say plus negative 10 minus 8 x squared plus 4x. Step, you probably will choose to skip, but important if you really want good understanding. Okay, so we end up with an 18x cubed because the 20x cubed and the minus 2x cubed. 20 minus 2 is 18. And then we end up with a negative 18 x squared here. So we just write plus a negative 18 is just the same as a negative 18 x squared and plus 4x. Now, if we check, just let x equal 1. If x is 1, then all we get is the numbers out in front here. We get a 5 and a negative 2, which is 3. We get 1 and 4 minus 2, which is negative 3, so we get negative 9. If we do that down here, we don't get negative 9, we get 9. And that can't be. So I think I did something wrong there. Yeah, I did. It's 3 times 3, not 3 times negative 3 is 9. And then 5 and 18 and negative 18 and 4. 18 and negative 18 gives you 0. 5 and 4 gives you 9. Chances are this is correct. We want a better check. Plug 2 in for all these. Plug 2 in for all these. Use your calculator so you don't have to spend all night doing the arithmetic and making mistakes like I do. Okay? If you make a mistake in the arithmetic, it's going to mislead you. So, when you're doing problems, when you don't have the answers in front of you, when you don't have something to tell you got the right answer, you do a check. Make sure it works. Okay. Now, spend a lot of time on that stuff, but it's really important to get all those concepts down. There are two topics we need to look at. Factoring, greatest common factor, and special products. Excuse me a second, let me just take another look here where we are and make a decision. Okay, I had to make a decision. I had to make sure things were in the order that works as far as your assignments are concerned. So I think that, okay, I want to look at this. Take just a minute, write this out, and then write out the distributive law and see what you get. Okay, so what we get is we're going to use the same pattern we do here. We're going to do A plus B multiplied by A, and then minus A plus B multiplied by B. And then we do the distributive law on this. We get A times A plus B times A minus A times B minus B times B. So we end up with this, and it's pretty easy to understand how that comes about. And matter of fact, I think at least one person was starting to just do it without doing the two steps. And it looked like it might have been going to be right. Okay, so what do we do about this? Well, now I've written A, B instead of A dot B just because it's quicker to write. Okay, that means A times B. This means B times A. Now what's B times A minus A times B? Well, it's zero because it doesn't matter in which I multiply two numbers, they come out the same. So B times A is the same as A times B. So we have A times B minus A times B. So this is A squared plus AB minus AB minus B squared, which is A squared minus B squared. Now this is a very handy thing. So we can kind of write this out as a special product. A plus B times A minus B is A squared minus B squared. Here's another special product. A plus B quantity squared. What's that mean? That means A plus B multiplied by A plus B. Now people will tend to want to just distribute the square well over the A and the B and write this as A squared plus B squared, but that's not right. That's not what A plus B quantity squared means. It means this times this. Now I'm going to kind of write this out linearly because I don't have much room down at the bottom, but this could be just written as using a distributor, A plus B times A plus A plus B times B. And then this equals, well, A times A is A squared. B times A is BA. A times B is AB. And B times B is B squared. And it comes out like this. It doesn't come out A squared plus B squared. It comes out A squared plus 2AB plus B squared. So here's another special product. Okay, two look like a two to get a little better. Anyhow, it's this. And there it is. Now, you're going to have to leave it to open math to show you a little bit more about how to recognize this one and use it because for the time. No, expose the board again in a minute. I left something off on one of these. See that +7? Now, it took the class to point out to me that I left that off when I simplified it. So I should have had a +7 here and a +7 here, and a +7 here, and a +7 here. And if I had done my check on this, it would have revealed that I was missing something. Okay, that'll come up 7 short. So again, another good reason to always check. Anyhow, here are two special products. And unfortunately, we don't have time to do anything with those because we spent a lot of time on the addition and multiplication of polynomials, okay? Even though everybody made 100% of the homework, it becomes clear that there are things that we needed to go over. Okay,